Good morning, students. Today we are going to discuss about that problems on maximum power transfer theorem. As we all of them may know that maximum power transfer theorem. So look at here the problem. Find the load RL that will result in maximum power delivered to the load for the circuit shown in figure 3.84. Also determine the maximum power P maximum. So for this circuit here we have to find out that what is the amount of power which is delivered from source to the load, that is maximum power P maximum we have to calculate, and we have to calculate RL value because in the given problem here RL value they are not given. So this is our ultimate aim, to find out that the unknown parameters in the given problem. According to the maximum power transfer theorem, the maximum power transfer theorem states that the maximum power is delivered from source to the load when source resistance is equal to load resistance. So, and one more thing we know that for the problem, if there is any difficulty to find out that P maximum value, and if they are not given the load resistor value, then we have to convert this entire circuit like a Thevenin's equivalent circuit as to find out the unknown parameters initially, like RL value. So here I want to find out that RL value. I want to find out the RL value initially. So for that purpose I want to approach that Thevenin's theorem as to find out the Thevenin's value and RTH value. I mean VTH and RTH. So now our aim is to find out that VTH value. VTH value is also called as open circuit voltage. Now the load resistor across the terminals AB RL value I am removed. Now I am looking from the terminals AB to find out that VTH value. What is VTH or VOC or VAB? Thevenin's voltage is also called as VOC, I mean open circuit voltage, VAB, I mean voltage across the terminals AB. Therefore, to find out the Thevenin's voltage here, I am going to modify that given problem as a modified circuit to find out that Thevenin's voltage value. To find out the Thevenin's voltage value at here, I am considering a current I which is flowing in this loop. If a current I which is flowing in this loop means, what is the current I? Because here VAB is nothing but 150 into I, because voltage formula V is equal I into R. Here V is equal, I means we don't know, I into R means here 150. That is Thevenin's voltage called VTH. Therefore VTH is equal 150 into I. So I want to find out that I here. How to find out that I? How to find out the value of I at here means, from the given circuit here we can find out that I. That is I is equal here V by R equivalent according to this given circuit. I is equal to V by R equivalent value. What is V? V is 180 volts here, and what is the R equivalent value? According to this given circuit, R equivalent value is nothing but sum of 30 ohms plus 150 ohms, because 30 ohms and 150 ohms both are connected in series and the same current is flowing, that is called as I. Therefore I is equal to 180 divided by, I mean V divided by R equivalent. Here V means 180 divided by R equivalent means 30 plus 150, 30 plus 150. So 180 divided by 180. So that becomes 1 ampere. Therefore the current flowing through this circuit I is equal 1 ampere. Now if I know that 1 ampere, then what is that Thevenin's voltage? That is VTH is equal 150 into I. Thevenin's voltage VTH is equal 150 into I here. Now I want to calculate that I. I calculated I. Now I want to calculate VTH. So VTH is equal 150 into I. Just now we got that I. Therefore 150 into 1. So Thevenin's voltage value is equal to 150 volts. If Thevenin's voltage value is equal to 150 volts, if Thevenin's voltage value is equal to 150 volts at here, then I want to calculate that RTH according to Thevenin's equivalent circuit. According to Thevenin's equivalent circuit, if I want to calculate that RTH means, from the given problem, in this given problem in this given problem, if there is any voltage source, that is 180 volts voltage source is there, we have to short circuit this 180 volts voltage source by considering its internal resistance, and we have to redraw the modified circuit as to find out that RTH. As to find out the RTH, this is the equivalent circuit or modified circuit where 180 volts voltage source is short circuited. Now I want to find out Thevenin's resistance or voltage, resistance across the terminals AB. If I want to calculate the resistance across the terminals AB or Thevenin's resistance called RTH or RAB resistance here, RT or RAB, what is the relation between 30 ohms and 150 ohms? The relation between 30 ohms and 150 ohms here, it is parallel. How we can say that it is parallel means, let us imagine there is a voltage source from the terminals AB. There is a voltage source. This voltage source drives a current, name it as I, and again this I is divided into two currents at this node. One current flowing through 150 ohms, name it as I1. Another current which is flowing through the 30 ohms, name it as I2. So the currents flowing 30 ohms and 150 ohms is not same, it is different. Therefore these two branches are in parallel. Therefore the R equivalent value here, that is 30 ohms is connected in parallel with 150 ohms. Therefore 30 ohms is connected in parallel with 150 ohms. Therefore RTH R is equal, RAB is equal 30 into 150 divided by 30 plus 150, that is equal 25 ohms. Now I know that equivalent circuit of that maximum power transfer theorem. According to the equivalent circuit of maximum power transfer theorem, now I know that the Thevenin's voltage, that is equal to 150 volts. Now I know that the Thevenin's resistance is 25 ohms. Now I know that the load resistance value is also equal to 25 ohms. How I can say that the load resistance value is also equal to 25 ohms? How we can conclude that the value of the load resistance RL is equal to 25 ohms? Because according to the statement of maximum power transfer theorem, the maximum power is delivered only at the case when load resistance value is equal to source resistance value RS or RTH. Now here RTH value is equal to 25 ohms. If RTH value is equal to 25 ohms, then RL value is also equal to 25 ohms according to the formula, that is RL is equal to RTH. Therefore from this circuit I can find out that what is the current I. What is the current I from this circuit? The current I from this circuit, I is equal V by R equivalent. What is V? V means here Thevenin's voltage VTH. What is R equivalent value? R equivalent value is nothing but RTH plus RL. Therefore I can become as 150 divided by 25 plus 25, that is 150 divided by 50. 50 ones, 53s. Therefore I is equal to 3 amperes. If I is equal to 3 amperes, then what is that? The maximum power which is flowing at here. The maximum power which is flowing in this circuit, that is the maximum power which is flowing in this circuit, that is P is equal, we can find that maximum power here by two ways. One is with the formula of I square into RL. One is with the formula of V into I. So please go through the formula of I square RL here. Now if I am going to find out that P is equal to I square into RL, just now I got I is equal to 3 amperes, that is 3 whole square into RL. What is the value of RL here? It is 25. 3 whole square 9. 9 into 25. 25 nines. Here 25 nines is equal to 225 watts. That is 225 watts is the maximum amount of the power which is flowing in the given circuit according to this problem. Thank you.